Our next test is the ratio test, and this one's a fan favorite. This one's pretty useful. I think you're going to like it. So it says the following. Let L be the limit as n goes to infinity of the absolute value of an plus 1 over an. Okay. Then, like the root test, I could say a few things about whether or not the series converges depending on the value of L. So the first thing I'm going to say is, if L is less than 1, then the sum, n going from 0 to infinity, of the absolute value of an converges. If L is bigger than 1, then this sum, absolute value an, diverges. And if L is equal to 1, then I don't know. It could either converge or diverge. So this conclusion is the same conclusion as in the root test, except I'm evaluating the limit L differently. I'm evaluating a ratio of terms. That's why it's the ratio test. So I'm not going to explain why the ratio test works in this video. If you're curious, you can look at the textbook. But for this video, I'd like to make sure we know how to use the ratio test. So here's example. What about the series n going from 0 to infinity of n over 3 to the n power? So the ratio test says I have to look at this limit L. It's the limit as n goes to infinity of the n plus first term. Well, you'll notice here in the statement of the theorem I have absolute values. Absolute values don't do anything if the terms are already positive. So in this example, the terms are already positive. I don't really have to worry about the absolute values. So I'm taking the limit of the n plus first term. So that means I'm going to plug in n plus 1 wherever I see an n. These are my terms an. So I'm going to plug in n plus 1 and get n plus 1 over 3 to the n plus 1 power. And I'm going to divide that by the nth term, which is n over 3 to the n. So I'm going to simplify this a little bit. I think I'm going to get n plus 1 over n times 3 to the n over 3 to the n plus 1. Now, this limit is 1/3. Why? This term here, n plus 1 over n, that has limit 1. So that goes to 1. And this term, I could see that the 3 to the n cancels with the 3 to the n on bottom, only leaving me with 1 over 3 to the first. So the limit is 1/3. Now 1/3 is less than 1. So we have convergent. So this original sum converges. Let's do another example with the ratio test. What about this sum going from 0 to infinity? How about this time we try n factorial over 3 to the n? Again, all my terms here are positive, so the absolute values in the statement of the ratio test don't apply. They're just in there just in case you have negative numbers involved. So let's do L. That's the limit as n goes to infinity. The n plus first term, so n plus 1 factorial over 3 to the n plus 1 divided by n factorial over 3 to the n. So simplifying, I don't like fractions within fractions, so let's simplify a little bit. I get n plus 1 factorial over n factorial times 3 to the n over 3 to the n plus 1. So just like in the last problem, this part's going to be 1/3. But n plus 1 factorial over n, here, let me write that here. This one's interesting. So this is the limit as n goes to infinity. N plus 1 factorial is 1 times 2 times 3 till I get to n plus 1. That's n plus 1 factorial. And n factorial is 1 times 2 times 3 all the way until I get to n. And I still have this 1/3 term. Now, all of these terms cancel with all of these terms, leaving n plus 1. So I have the limit as n goes to infinity of n plus 1 over 3. That's infinity. That's case 2 here. The limit is bigger than 1. So my original sum diverges. Let's do another example. Let's do one we already know and see how the ratio test works. So, what if I did the sum 1 over, actually let me start at 1 over n squared. Okay, I know this is a convergent series. It's a p series with p equals 2, convergent. But what does the ratio test tell us? I have the limit as n goes to infinity. I'm getting 1 over n plus 1 squared divided by 1 over n squared. So I took the n plus first term, plugging in every n with n plus 1, and dividing by the nth term. So this is the limit as n goes to infinity of n squared over n plus 1 squared. If you'd like, this is the limit as n goes to infinity, n squared over n squared plus 2n plus 1. This limit is equal to 1. It's a polynomial divided by a polynomial, so I have 1n squared over 1n squared. These terms here are insignificant compared to the n squared, so the limit is 1 divided by 1. That means I'm in case 3. That means the ratio test tells me no information. I already know the series converges. It's a p series, but the ratio test does not help decide anything for me. So that's an example of when the ratio test is inconclusive. Okay, let's do one final one. How about this? What if I did the sum n going from 1 to infinity? Let's do n times 3/4 to the n power. Okay, so I'm going to use the ratio test. The limit as n goes to infinity. The n plus first term would be n plus 1, 3/4 to the n plus 1 power. Divide that by the nth term, so n over 3/4 to the n. Simplifying a little bit, I get n plus 1 over n times, now when you simplify the 3/4 to the n plus 1 over 3/4, I think you're just going to end up with 3/4. So all the powers cancel except for one power in the top. This limit, n plus 1 over n, is 1. So the actual limit, 3/4. 3/4 is less than 1, so I'm in the first case. So the series converges. So there's the ratio test. You got to get used to this one, so get some practice, and I'll see you next time.